Hi and welcome to this video about process enumeration in Windows. So first we need to understand what process enumeration is. The idea here is that I want to get a list of all the processes in the system. Now why would I want to do that? This could be because I'm searching for a process with certain attributes such as a certain executable name or some other property. Maybe I want to see the lay of the land, see what kind of processes are running on that system. Maybe I'm trying to accomplish something or exploit some process that I think I know how to do. There are ways to check whether I'm running within a container, and one of these ways is to list the processes that I see. If I see a very small number of processes, then I probably am running under a container, because a typical Windows system has dozens, if not hundreds, of processes. And then sometimes we want to keep track of various processes for whatever reason. So in this video, we'll see some ways to perform this kind of process enumeration. We'll focus mostly on the Windows API, but we'll also see one way to use the native API. The Windows API has three nice APIs to use. The first one is called the Tool Help API, which is fairly easy to use and provides a decent amount of information. Then there's another API called the Windows Terminal Services API, and although this hints as to the fact that this is used for terminal services environment where you have multiple sessions perhaps running on the same system, this API actually works on a normal local machine even when there are no terminal services connected at all. And then finally there's the Enum Processes function, which is like a bare minimum function that only provides process IDs. And as the last example, I'll also show you how to use the native undocumented anti-query system information to get more details about processes than any of the other APIs really. So let's begin. Let's go to Visual Studio here and create a new project. Let's call this project just prog list. And we'll create multiple functions. Each one would work with a different API. So let's start by doing the usual includes for Windows.h and maybe display some stuff using stdio to have access to the printf function. And let's start with enumeration using the tool help function. So let's call that enumproc tool help. With the tool help functions, we need to create a snapshot. In fact, this requires yet another header. So let's add that header, tlhelp32.h. And then what we're going to do here is create a handle to a snapshot. This is how that works. So we have the create tool help 32 snapshot. In fact, this snapshot can contain processes and threads, and also it's possible to enumerate modules and heaps within a particular process. What we want to do here is to get a list of processes. I'm just going to use the snap process flag here, and the process ID in this case has no meaning and we need to provide 0 here. If that fails, it returns invalid handle value, which is fairly unique. If this is the case, there's really nothing for us to do. I'm just going to return here. This is unlikely to fail unless your system is really low on memory. So now we can go ahead and enumerate processes. And for that, we need to create this data structure called process entry 32. And don't let the number 32 fool you. It works with 64-bit processes just as well. And this is just like an old name from the 32-bit days, but it actually applies to 64-bit in exactly the same way. The only thing we need to do here is to initialize the size of the structure. And now the way to work is to call first the function process32 first. When we get the process information for the first process, so we need to provide the handle to the snapshot and the address of this object. And then technically we can look at this first process, which is going to be the system idle process. So in any case, we can display some information that we have, such as the process ID. Let's do something like this. Let's say we have also the parent process ID. Let's have that here as well. And then there's also a way to get the number of threads there because it is provided by the structure there. And finally, let's just get a name here, which is also something we get. So if you look at the PE structure here, we can see there's the process ID. So we have that one here. And then we need the parent process ID. We have that as well. And then there's the number of threads, thread count here. We have that. And then finally we'll take the name. In fact, there's not much else in here. It might seem like we have some other stuff here, but in fact, most of these things are reserved or not really provide any kind of useful information. Maybe you might want to look at the base priority of the process, but for now we're going to stick with these most useful members here. And the next loop is just using the function process 32 next to get the next process in line. And this function returns false once the iteration is done. So at this point we can just close the handler to the snapshot and the function is done. And by the way, the snapshot here behind the scenes is actually a section object, a file mapping object that stores all the information. That's why closed handle makes sense, because it is in fact a section object behind the scenes. Okay, so now that we have that, let's test it. And we need to, of course, call it. So let's use enum proc and then call the tool help function, see what we get. So I'm going to build that, press Ctrl F5, and here goes. We can see the list of processes here shown in a fairly easy way, including processes that are special. They are kernel processes that don't really belong to user mode. They're not based on some executable, such as the system process. The system process here, in fact, is the idle process. This is just some default name the tool help API provides for this process. Normally, this is not a true process in the full sense of the word. It doesn't really have any kind of name, so you can have anything you want here. And so we have these special processes like the secure kernel, the registry process, and then there's some other normal user mode processes that we see right here, each one with its own process ID, parent process ID, and number of threads. So that's fairly nice, and we get some decent details here about the process. Let's now look at the other two options. So we have enum proc. Let's look at WTS, the Windows Terminal Services API. So for the purpose of this API, we need to add yet another include here, which is called WTS API 32. So what can we have here? There's a bunch of WTS functions, and so one of them is enumeration for processes. So we have enumerate processes. In fact, there's a few versions of that, two versions really, where you can provide or get different levels of detail. In fact, two levels of detail are currently supported. So first we have the handle to the server. So technically this could work on another machine. So you can query another machine from this machine, which is kind of unique because the other APIs don't provide that kind of capability. So we have the server here, and the server in this case is going to be just current server handle or something, which is technically just a null. So we can just put null here to make it a bit simpler. There's a level parameter here, which actually, weirdly enough, has to be equal to 1. This is the only one that is currently supported. Of course, this is all documented. And then we can provide a session ID. I think we can use something like any session that we want to get all the processes in all sessions. We don't want to focus on a particular session, but we could, which gives some flexibility to this API as well. And then the result is actually going to be some WTS process info EX structure or array of that kind. So let's call that info. In fact, we need to provide the address of that info. We also get how many processes we actually get back from this enumeration. And so the type here looks a bit weird. The type here seems to be like a string, but it's not really a string. It's just anything we want really. And this is just a way to provide the generic type. I don't think it's a good idea. It's better to use something like a void pointer or an address to a void pointer, but it is how the API is built, so it's not really up to us anymore. If that fails for whatever reason, there's really nothing to do. Let's just return. Otherwise, we can try and work with what we have here. So well, actually, I should be pointing here to the pointer to the string, just like the function sort of expects, but it's not really going to be that. So with that in mind, if that in fact works, we can go ahead and iterate over that array that we get back. So in this case, the function allocates the memory. We're supposed to use that and then free that memory using the function WTS free memory. This is what the documentation says. So just pass that info pointer and let it be properly released. So in this case, the only thing left to do here is actually to walk over these processes. So let's go and grab this WTS thingy here, the process. We can just go and use the index if we so desire. It doesn't really matter that much. Of course, we have info here. And now p dot provides all the information. As you can see here, there's lots of details here, a little bit more than we find in the tool help APIs. So let's see. We first might want to display the process ID as before. Let's do that. We also have number of threads. So let's take that as well. And then we also have the number of handles. That's something we didn't have previously. So let's grab it as well here. And of course we have the name, and we'll see what else we can get here. So let's see, let's start with the process ID. So we have the process ID. There's also the session ID. So let's just grab it as well. So we have a session. Let's call it session. I think it makes more sense. And so we have the process ID, we have the session ID, and then we have the number of threads. So we have number of threads. We also have the handle count, number of handles. Let's see what else we have here. We have the process name. So that's kind of obvious. But then there's also other stuff such as the page file usage, which is about the commit size of the process, the peak working set, and the peak commit size. There's also a pointer to the user seed, which is available for certain cases, especially if you run with admin privileges, and we can take that seed and convert that to username if we so desire. So let's go ahead and do that as well. There's also user time and kernel time, lots of interesting stuff here, much more details than we find in the tool help APIs. So let's select just something to look at, like the working set size. So the working set size is really the amount of memory, physical memory used by the process. So we can have name here, and then let's add memory or something like this. Let's go with something like in megabytes, say. So I'm going to shift by 20 to get megabytes, and let's also display the seed in its string form at the very least. So let's go ahead and get a function here like seed to string seed. I'm going to return a string here, provide the user seed, and if it's not null, we're going to deal with that. So that's going to be now, and we can continue that loop for the rest of the process. So let's just add this seed to string seed for fun. So let's return a string, and we need to get a seed here. Don't have a definition for string just yet. Let's just go ahead and do that. So let's add header folder for string to get the string class from C++ standard library. Now, if seed happens to be null, there's really nothing we can do in this case. It means we don't get the seed. So let's just return an empty string and be done with it. Otherwise, we're going to call the function convert seed to string seed. There is such a function. However, it is in a separate header, if you can believe it, that's called SDDL, which is short for Security Descriptor Description Language, if you can believe that. Anyway, the function is just there, so we have to call that, and we need to provide the seed. Here goes the seed, and then the result is going to be returned to us as a string, but again, this function is going to allocate that string, so unfortunately we'll have to grab it and then free it before returning it. So result is going to be our sseed, and then we're going to free that using the function local free. Why local free? This is just what the documentation specifies. It says, please call local free once you're done. Fine, then I'm going to do that, and we can return this result. Otherwise, if this function fails for whatever reason, then we have nothing left to do here. So let's try this out. Let's go to enum proc and then change that to WTS. Okay, too many parameters here to user seed. Let's see. So we have the process name, handle count, the session ID. Let's see, number of threads, handles, process name, memory, and we forgot the seeds. Okay, good. So let's have the seed here, like so. So let's run this, see if that works. So we have some errors here. These are linker errors. and these are because as the WTS API happens to be implemented in a separate DLL, which is not added by default to the list of import modules. So I'm going to just add that. I believe this is the name, WTS API 32. Again, don't take the 32 too personally. Now it links OK. Let's run this, see what we get. And indeed, we get some information here, which is perhaps richer than what we've seen previously. We now have the seed as well, and some memory information, the session ID, things like that. And of course, it is possible to even go further and change or translate or convert the seed itself into the username that it represents or the group name that it represents. I'm going to leave that for another time. The last API I would like to mention here, part of the Windows API, is the Enumerate Process, Enum Processes really. So let's just call that, create another function for that purpose, call that Enum Processes Raw. I think that's a good name. So Enum Processes is like the simplest possible function you could imagine. It just returns number of processes, the IDs of processes, and fortunately, let's see, it seems like this one is not properly compiling, just as we perhaps expected, but Enum Processes doesn't seem to compile, which means we probably are missing another header. So maybe that would be the PSAPI API. It's another, the process status API. So now Enum Processes does compile. So we need to provide the array of process IDs that we're able to accommodate. And in this simple example, I'm just going to create something which is static in size. So just say I have 1024 PIDs I can accommodate. And of course, we can write something a bit more elaborate to make sure that if we don't get the entire set of process IDs, we can reallocate something and try again. But for now, I'm just going to stick with this simple plan, and then we get back the number of bytes that we actually needed. So we have that, and if we compare that, and we compare that to the array size that you provide, then if we get the number to be the same, it means that we're probably missing some IDs, and you should run this code again, or try to reallocate and try it again. So if Enum Processes returns false, it means something went wrong. Otherwise, we have the number of IDs here, and the only thing really that we can do at this point is just to go ahead and look at how many we got back, and that would be whatever is needed divided by the size of dword, because that's returning number of actual bytes we need. So we either are missing some processes or we have everything. At this point, we want to display the process ID. Obviously, that's the only thing we really have. So that is kind of perhaps a very poor API for that purpose. But of course, it's probably fastest because there's really almost nothing that it provides. So you can definitely go ahead and display the ID here by looking at the index array here. But if you want to get anything else out of that process, the only recourse is to open a handle to the process and hope for the best. So let's say I want to get some kind of process, say process name. So I can use the Open Process API to try to get that information. I need, in this case, the query limited information, which is the least privileged access I can have to a process. That's good enough to get the process executable name. The inheritance bit doesn't really matter, and the process ID is, of course, something that we have. So we're going to get the handle to the process, but of course, it may or may not work. It won't work for all processes, but if it will, if it does work, then we can go ahead and move forward. Let's use something like an array here for the process path, the executable path. Let's give it some size. Let's say max path here, and the size we have to provide the count of number of characters, which is essentially the same as max path. And the reason is that I need to call a function query process full something full process name. Let's call that query full process image name. That's the function. Here's the handle to the process. Flags 0 is just fine. and then the path itself here. In fact, the size, I have to provide the address of that, so it returns the actual number of characters that were used. So if that works, then I have a name here I can display, and then the name is going to be whatever we got back from path. So that's nice, and we can now close the handle to the process, and that is essentially it. Let's go ahead and use \n here. So let's try it, see if we get something which is at least marginally useful. So we have enum processes raw here. Let's execute that. So here goes. And so here's what we get. We get indeed the executable names here, which is definitely what we were after. But you notice that in some cases we get nothing, like in these processes right here. We don't seem to get anything for these processes, and that's because we can't open a handle powerful enough. And so to fix that, or at least partially fix that, we can try to run this with admin privileges. Let me restart Visual Studio here, running with admin privileges. By the way, if you don't see that option in your file menu, it means you just don't have one of these nice extensions called Twix 2022, which you can use to get some nice, I would say, helpers in Visual Studio. And one of them is these two options here to restart normally or restart with admin privileges. So if we try it now, let's see what happens in this case. So now we should be more successful in the sense that the first processes here, you can see that now we do get the executable names as we would like them to show. However, there are some processes where we get nothing, and the reason is that these processes are special. These are the system process, the idle process, the secure system process, registry process. These are kernel processes that are not do not depend on any kind of executable name, and this is why we get absolutely nothing here. That's because the function query full process image name can only retrieve executable names. In fact, there's no good API after you just have a handle to get the process special name, so to speak. So all the other APIs we've seen here have that nice advantage. So this is enum processes, could be useful for certain cases because it is the fastest API to work with. However, any additional information you might need, you'll have to open a process which is probably going to take you more time and be more costly. So probably you want to use one of the other APIs, the tool help or the WTS APIs, to get the details that you need. Now there's another API I wanted to show you, which is the native API. But since this video seems to be a bit longer than I expected, I'm going to defer that to the next video.